In this video, we're going to learn about how to classify the shape of distributions, which are also graphs. So taking a look at these first three graphs, we have a dot plot, a histogram, and a box plot. These are all symmetric graphs because if we draw a vertical line down the middle, both sides are going to look the same. So if you look at this dot plot right here, if we drew a line right down 12, 12 is our middle. On the left side and the right side, it looks exactly the same. Same thing for this histogram. We draw a line down 12. The left and the right look relatively the same. Same thing, draw the line down 12 on the box plot. The left and the right look the same. We also say these graphs are bell-shaped because they're shaped like a bell. So take a look at this bell right here. We see that the bell starts out low, goes high in the middle, and then comes low again. We can see that in the dot plot where we start low, we come high at 12, which is our mode, and then we come low again as we head further down the line. Same thing with the histogram. We start low, the middle is the highest point, and then we come low again. It's pretty challenging to see this in the box plot, so we really talk about bell-shaped with histograms and dot plots. These next three graphs are what we call skewed. And the reason why they're called skewed is because one side of the graph has a lot more data than the other side. So you'll see over here on this dot plot, 8, 9, 10, 11 have a lot of data points. And then as we go further down the number line, we see that there are less and less data points. That's also reflected here, where the highest bar on our histogram is all the way on the left-hand side. It's not in the middle like it was on the slides previous. Same here with the box plot. Our box plot is leaning more towards the left. It's not really in the middle anymore. We can say that graphs are skewed both ways, where more data might be on the left, as it is in this case, or more of the data might be on the right. It kind of depends on what the situation is, but in both situations, we would call them skewed distributions because majority of the data is either on the left side or the right side of the graph. These three graphs are called uniform distributions. And the reason why they're called uniform is because everything is the same. You'll see that each of these data points all have two dots above them. There are 4, the height of each of these bars are 4, which means there's 4 data points that fall between the intervals 7 and 9. And in the box plot, you can see from the minimum to Q1, and from Q1 to the median, median to Q3, and Q3 to the maximum, all those intervals are equivalent to each other. They're the same distance. We also say that these graphs are symmetrical because if we divided the graphs down the middle, like we did with the first set of graphs, the left and the right side are going to be the same because everything is uniform. So sometimes graphs can be described in two different ways. They could be uniform and symmetrical, or bell-shaped and symmetrical. You're really never going to see a skewed symmetrical since the skewed has everything that's over onto one side. The last type of graphs are bimodal. And the reason why they're bimodal is because we have two different modes. We have two different highest points. So we have a high point at 7 and a high point at 18. You can also see this in the histogram because we have a high point in our first interval, 6 to 8, and a high point in our last interval, 18 to 20. What happens with a bimodal distribution is our data, as you can see in our box plot, gets pulled towards the minimum and the maximum because that's where our modes are. They're closer to the minimum and the maximum. We could also say that these graphs are symmetrical again because if we divided the graph down the middle, the left and the right side would look very similar to each other. So again, a graph can have two different distinctions of what they would be called based on their shape. Again, anything that's symmetrical is what you divide down the middle, and the left and the right side are the same. Thanks for watching.